following has been developed by state and provincial education agencies in association with the Agency for Instructional Technology. Together, programming for today's learner.
Well, do you know what you're doing?
No, ma'am, I don't.
Well, the library is organized according to the Dewey Decimal System. The Dewey Decimal System. This means that there's a number like this one on every book and a place for every book. Go ahead and try it.
Harry gets a haircut.
Just ignore the titles.
Billy and the Snoop Machine?
As I say, ignore the titles and look at the number. The larger numbers are more towards the far end, while the smaller numbers are more towards this end. Try it.
Yes, ma'am, I'll try. Well, all the whole numbers are the same. So let's look at the decimals. She said the larger numbers are at the far end. .156 is larger. So it must be down at the end.
That's what he thinks.
He'll never find it here.
Let's see. These numbers seem smaller. I don't get it. That's not what Mrs. Nielsen said.
He'll be here all day.
This is getting too weird. I'm sorry. Really.
That's okay.
You work here?
Just started. You?
Uh-huh. Jeremy's my name.
Lucille.
Can I ask you something?
Sure.
See these two books?
Billy, and the Snoop Machine?
Just ignore the titles. .156 is larger than .6, right?
I guess.
Then how come it's down there with the larger numbers?
I don't know. Let's look.
Before we met, were you saying something to me?
No? Why?
I don't know. I just kept hearing voices.
Jeremy has a problem.
And it's not just hearing voices.
Jeremy assumes that the more digits, the larger the number.
Which isn't necessarily true.
Watch this. This decimal has 3 digits, while this one only has 1. Now, if you were to assume that this one was larger,
You'd be wrong. Just because there are more digits in a decimal number doesn't always mean you have a larger number. You have to look at the place value of the digits. Watch what happens if I put a couple of zeros on the end of 6/10. We get 600 thousandths. Now we can compare two decimal numbers more easily.
you can more easily tell that .600 is larger than .156.
Yes, but I can hear the wheels grinding. How can you just put zeros on the end of a decimal without changing the value? And it is certainly true that if you were to do that with a whole number, you would be changing the value.
If I was to put 2 zeros to the right of the 6, I'd get 600. Obviously a different number and greater in value.
Yes, but by putting zeros to the right of the decimal, you do not change its value. The zeros are just placeholders.
But it makes it a whole lot easier to compare values when the number of digits is the same.
Think of these identical chocolate and vanilla cakes as
Delicious.
whole numbers. Now each one represents 1. So we'll divide the first cake into 10 equal length strips. The second we'll divide into 100 equal squares.
If we take half of the first cake and represent that as a decimal, we have 5/10, or 0.5. Now if we take half of the second cake and represent that as a decimal, we have 50/100, or 0.50.
But as you can see, 0.5 and 0.50 represent exactly the same value. They cover the same amount.
So by putting zeros on the end of decimals, you're not actually changing the value. But more often than not, you're just making it easier to compare decimals having different numbers of digits. Besides, it's delicious.
We have to start all over again.
Oh, we need help.
We need a system.
Yeah.
Hey, all these books are from the same section. So they all start with the same whole number, 791. So all we have to do is compare the decimals. This is what we should do. We'll compare the decimals. First the tenths, then the hundreds, then the thousandths.
Looks good. Let's try. .6 is the same as .60, which is larger than .42. So it goes here.
I've got .300.
I've got a .307.
Okay. Wait a minute. That's not right.
What?
Well, the threes are the same, and so are the zeros. So we have to keep looking to see which is larger.
And 7 is definitely larger than 0.
Right. So .307 is larger. There.
Let me see if I've got this right. Check the digit furthest to the left first. If it's larger, the decimal's larger. If it's the same, then check the next digit, and so on.
What about these two?
Check the digit furthest to the left first. 6, both the same. Then check the next digit. 8 and 5. 8 is larger than 5, so .689 is larger than .652.
Right.
You have to make sure that you systematically check the columns, the tenths, the hundredths, and the thousandths columns.
The 10,000s, or even the 100,000s column.
Right. When you are comparing the value of decimals.
You're about to meet someone who deals with these kind of comparative decimal problems all the time. He uses decimals with a lot of digits every day in his work.
My name is Helmut Bauer. I'm the chief tool designer for de Havilland Aircraft of Canada. Our function is to design tools which enable us to produce aircrafts to close tolerances and measurements. An engineering drawing is actually produced on a computer-aided design. It's a screen like your picture tube, and you can draw on that screen. Any dimension in the mechanical design is usually given in 3 decimal dimensions, meaning we are going down to 1/1000th of an inch. Our goal is to achieve perfection on any measurement, but we are not able to be perfect. So we have to give us a limit which we consider acceptable. That limit is what we call the tolerance. Tolerances are of utmost importance because they do assure that things fit together. If you are having an aircraft and you would like to have a door installed, you would like to have a door sent to you that does fit. In order to achieve that, you have to work to these close tolerances. The plane could crash if our measurements would not be accurate. Since I'm from Europe, I have no problems with decimals because that was what I knew from day one.
There's 2 things you gotta remember if you're gonna be successful in your job. First, the Dewey Decimal System.
The what?
The Dewey Decimal System. There's always a number taped on to this book and other books. Say you have 0.756, 0.8, and a 0.788. Where did they go?
Well, 0.756 goes here. 0.8 goes there. And 0.788 goes in between them.
That's right. And the beauty of this thing is that if you get more books in this category, you can always fit them onto the number line.
I don't understand.
There's always another decimal between 2 given decimals. Check this out. Between 0.2 and 0.25 is 0.21, 0.22, 0.23, and 0.24. Between 0.24 and 0.25 is 0.241, 0.242, 0.243, 0.244, and so on.
Right, I get it. In between 0.249 and 0.250, there's 0.2491, 0.2492, etc.
Right. You can always have another number because there's always a place for another book.
All right, that seems simple enough, but you said there were 2 things I had to know to work here.
Oh yeah, well ordering the decimals is important, but more important is don't forget to pick up Mrs. Nielsen a chocolate bar for her afternoon snack. She gets real crabby without it.
I'll try to remember. Thanks, Jeremy.
Solve It was supported in part by the National Science Foundation. This program was produced for AIT by the Filmworks. This program was produced under the supervision of the Agency for Instructional Technology.